Hey, what's up? What's up, y'all? It is Tuesday, April 16th. We are on another video lesson. We got a little bit of notes to take. We got some Lincoln literacy to complete, and we got the third trimester goals check-in. Hopefully, you got all of your stuff turned in yesterday. The patterns in a system, page 48, that was due yesterday. Lincoln literacy due today. Third trimester goals check-in, that is also due, guess when? Today. So get to work, peoples. All right. So first things first is right here. Kinetic energy and potential energy study guide. There's also the quizzes if you need this stuff, okay? Because you want to retake the quiz, make sure that you study before you retake it. Because if you don't know it, then you don't know it. You need to study. Spend some time reviewing, okay? His email address is down there, Mr. DeFoy. I will not be here. So I won't be here till Thursday. So if you want to retake the quiz, then email him, arrange it with him during lunchtime, and then that's that. Okay, so it is note-taking time. Constellations in the sun. So remember what we talked about yesterday. So we talked about this idea that constellations, right? They're a group of stars, right, that are in the night sky, and it's about how they're arranged based on our view from Earth. So it's the pattern that they make in the night sky based on our view from Earth. Also, we talked about a star. That's a celestial body consisting of a mass of gas that's held together by its own gravity, in which energy is generated by nuclear reactions, okay? So there's nuclear reactions happening, right? Now, the closest star to us, we call that the sun, and that's a luminous star around which the Earth and the other planets revolve, and it's composed mostly of hydrogen and of helium, and it's ramming those hydrogen atoms together, creating nuclear fusion, boom, and then out of that comes massive amounts of energy. Now, people are like, oh, what about nuclear power plants? Let's just talk about that for like a hot second. So nuclear power plants, they do the opposite. They take an atom and they cut it in half. We call that nuclear fission, okay? So, and then energy comes out. Now, the amount of energy that comes out of that is way less than when the sun actually rams those hydrogen atoms together, and then boom, come out of them creates helium in nuclear fusion. Now, just last year, we actually, for the first time, were able to start to stabilize nuclear fusion reactions, because that is what we're actually thinking of doing. One sustainable way is, like all of these renewable energies, but we're also thinking of, okay, what's a cleaner way to actually get more nuclear energy? So that is one way, and they're talking about nuclear fusion and the massive amounts of energy that can come out of that. So scientists are working on trying to replicate what we see in the sun. Okay, cool. And then solar systems right down there. Solar systems right down there. Remember, it's a star. There's a star at the center and a group of planets and other celestial bodies that are held by its gravity. So held by the gravitational attraction of the star. Okay, those are the things we had yesterday. Let's move on to something new. So here we are, astronomy. Now, we've talked about this. Now we're going to give it a definition. Again, write this in your journal. Astronomy, the branch of science that deals with celestial objects, space, and the physical universe as a whole. So that astronomy is, sometimes people think of it like, oh, it's just outside of Earth. No, it's the Earth, but then its place in the galaxy, in the universe, in the solar system as a whole. So it's a branch of science that deals with all of these things together, because a celestial object would be considered, right, the Earth. There you go. Okay, so that is what that is. All right, now we're gonna, and I want to make sure it's clear, because we've chopped this up, and I'm gonna keep chopping. I want to make sure it's clear. There's this other thing that we think of, and it's called astrology, right? And that's different. It's the study of the movements and positions of celestial bodies. That part is very similar, right? Very similar to astronomy. Here's where the difference is. And astrology, they interpret it as having an influence on human affairs in the natural world. So it's saying, yo, we think the movement and the positions of these celestial bodies, these planets, these stars, they have an influence on how people act and how the world actually works. That's what astrology is. That's a completely different thing. So that's not what we're studying, but I'm just letting you know what that is. That's where these people get horoscopes from and saying like, oh, well, if you're born in this month, and that means these planets were near you, and this star constellation was by you, and so because of that, then this and this and that happens. And then you guys are looking like, well, how come the constellations are visible at different times? It's because astronomy is not necessarily concerned with how it affects human beings, or if there is an effect. It's more concerned about what is actually happening and what physical things can we study and actually see happening with actual facts. Does that make sense? With actual facts and things that we can study. So that is the difference between astronomy and astrology. But I just want you to know what this is, okay? All right, cool. So let's pause right there for a minute, because I think I didn't put this slide in, but I want to put in a slide for, I think I got one more note to take. Yep. All right, celestial, okay? And we're not talking about them people from Marvel, the Celestials, okay? No, we're talking about celestial, even though this definition would work for the Celestials in Marvel, but it's positioned or in or relating to the sky or outer space as observed in astronomy. So celestial bodies, celestial objects. So it would be objects that are positioned in the sky or outer space that can be observed. You know what I mean? And astronomy is the study of these things. So it could be like stars, planets, moons, asteroids, comets, nebulas, star clusters, right? So a cluster of stars that are close together, galaxies, pulsars, quasars, you know, black hole, dark matter, anything that is out there, right? That is a physical object that we can observe out there in space, that would be considered a celestial object, okay? So cool. So we are currently we live on a celestial object, right? And we call that celestial object Earth. Cool. So hopefully everyone's cool with all of that. Okay. So let's just talk through this. I'm not going to answer every single one, but we're just going to walk through this pretty quickly. This part, you should have really walked through this part yourself. So there really isn't too much for me to say over there. Okay. But so I'm going to go ahead and just go over here to this part. So a rotation, you should have found 3 things from the text, and it should be that it spins on an axis 24 hours on Earth, right? That's another thing. And it does cause day and night. Okay, let's talk about a revolution. Orbits an object. So it's how long it takes to orbit an object. If we look at Earth, it's 365.25 days. Remember we talked about that with the leap year? You know what I'm saying? We talked about like how that works. And then this causes years. Lunar phases. Now this is the moon reflects different amounts of sunlight as it revolves around the Earth. Depends on the relative position of the Earth, the moon, and the sun as to how much that happens. And then a new moon, a waxing crescent, the first quarter, the waxing gibbous, right? The full moon, the waning gibbous, the third quarter, and then the waning crescent. And you're like, what? Those are all the different phases of the moons and their names. Okay, seasons, right? Caused by the tilt of the Earth. Remember that. Caused by the revolution of the Earth, right? So depending on, is the northern hemisphere closer to the sun or further away from the sun, depending on its tilt, right? And each season lasts approximately 3 months. And then here's the thing too, is about seasons. They last approximately 3 months unless you're closer to the equator. And here we'll talk about that right now. Okay, boom. Unless you're closer to the equator. Because if you are closer to the equator, right, then no matter what time of the year it is, right, when you spin around, the sun's rays are beaming about the same. So the people in this zone, their weather is approximately the same a lot of the time. And if you look at these zones, if you ever been to some of these places, they're very tropical. You see a lot of heat there. Usually you see quite a bit of rain. These are places where rainforests often are as well. These are the great grasslands of Africa. So again, these places have approximately, the closer you are to the middle of the earth, then the more the sun is just beaming there all the time, and you're not necessarily that much further or closer to the sun. So because of that, like the people here near the equator, their weather is pretty similar most of the year, right? Most of the year. That's why people who live at the bottom of Florida live closer to the equator, right? They're like, hey, I know it's supposed to be winter, but it's 70 degrees outside and I'm having shorts. I'm like, bro, what is this? Okay. They're like, it's 80 degrees and we got shorts. Yeah, it's Christmas though. So again, that's just something to think about. Like the people on the equator, their weather is relatively the same because the sun is relatively about the same closeness to them the majority of the time. Okay, eclipses. So solar eclipses is when the moon's shadow is on Earth. That's what we just had. A lunar eclipse when the moon moves into the Earth's shadow. So that's a lunar eclipse. And then the only time when all three celestial bodies line up in the same plane. Because sometimes it's maybe a little bit higher, a little bit lower, like things. But we got to be lined up directly in the same plane to be able to have that happen. Okay, let's keep it going. Now, on to this last page. So that was page 71, 75. Let's talk about this last page real quick. So this last page, right, is you use the image, right, in STEM scopes to kind of see some things. So hopefully you guys are good with when it's winter in the northern hemisphere, then that means it's the opposite in the southern hemisphere. So summer. So if it's spring, right, for us, then it's fall for the people in the southern hemisphere, so South America. So when it's summer here in North America, it's going to be winter in South America. So when it's fall here in North America, then it's going to be spring there in South America. So again, since we're in different hemispheres, it's going to be the opposite, okay? And it has to do with, again, the tilt of the earth. So the explanation, right, is northern hemisphere is tilted away from the sun and receives less direct sunlight. That's why there's winter in the northern hemisphere. Again, in the spring, northern hemisphere is tilted neither toward nor away from the sun and receives the equal amount of sunlight. That's why spring's temperatures are about the same, right? And then when you get this, northern hemisphere is tilted toward the sun and receives more direct sunlight. That's how it just temperatures go up, 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 up. And then in the fall, we begin to be in that median. And that's why if you notice, spring and fall typically kind of have very similar-ish, right, temperatures, right? Especially at the beginning of spring and the beginning or the middle of fall. Like they have some of these same temperature ranges because they're not necessarily tilted. They're kind of like even at that point of the year. All right, so hopefully that helps y'all out with everything there. If you missed anything, you can ask the sub. They have all the answers if you need anything. Last thing. Oh, and this is due today. Tuesday 4/16. This is due today. There is one last thing that you actually need to do. It's the check-in for your third trimester goals. That is the last thing that you need to do. And if we just read these, so if you just read these, check your third trimester goals in the back of your scientific journal. That's one. Number two, please type a 5-sentence paragraph in the text entry box below about how your third trimester goals are going so far. So claim about the goal. So is it going good? Is it going bad? Then you need to have 3 sentences that actually support, like, oh, it's going good, and these are the reasons why, right? Conclusion, you should be able to do this. This is just like a reasoning paragraph. And then make sure to click submit and turn in your assignment. So you would click start assignment, type everything out here. Okay, type everything out there, get everything good, and then you just come down here and you click submit. You're done. You're done. And that is actually also, I'm going to leave student view. That is also due, guess what, fam? Today. So y'all need to get on it. Y'all need to get on it. It is due today, April 16th. All right, y'all. Peace. Have a wonderful day. I don't know if I have anything left in my slides. Nope, that's it. That's it. That's it. And that is it. So love y'all. One more day. Tomorrow, I'm trying to see if we can make sure to do a digital online lab. Peace.